Okay, let phi is equal to xz divided by x square plus y square at the given point p is equal to 1 comma minus 1 comma 1. Correct. So this is the given surface phi and point p, and the given vector a, he has given it as I minus 2j plus k. Okay, now let us see the gradient. So first thing we need to find is gradient, right? In finding directional derivative, first we need to find the gradient of given surface. So implies gradient of phi is equal to del phi. So how to define del phi? Dou phi by dou x I plus dou phi by dou y j plus dou phi by dou z k. Correct. So implies we need to find derivative of phi with respect to x, y and z to find gradient. Okay, so let us do that. So del phi is equal to dou by dou x of xz divided by x square plus y square into I plus dou by dou y of xz divided by x square plus y square into j plus dou by dou z of xz divided by x square plus y square k. So this one is equal to, so how to find the derivative of u by v? So where here xz and x square plus y square are the functions of x, correct? So you have to apply u by v rule for this. So what is u by v rule? D by dt of or dx of u by v, where u and v are the functions of x. So what is it? V into du by dx, or you can write it as vu dash minus uv dash divided by v square, right? So you are going to apply the same thing here. Okay, so v means x square plus y square into u dash. So what is u dash? Xz. Xz differentiate with respect to x. So how much you'll get? Z minus xz separate, differentiate x square plus y square. So I'll get 2x. Okay, divided by x square plus y square into I you'll get. Correct. Plus, is it audible, right?
Yes, sir. Yes, sir.
Next, in the same way, you have to apply differentiation with respect to y. So if you apply with the differentiation with respect to y, first x square plus y square into 0 will get, because in numerator y function is not there. Okay. Next, minus xz into differentiation of x square plus y square is 2y divided by here x square plus y square whole square you have to write. Whole square. Okay. Into j plus here x square plus y square, differentiate with respect to z now. So I'll get x here minus xz into differentiate this one with respect to z. So I'll get this one 0 divided by x square plus y square whole square. Okay. So now proceed it to find del phi value. So this one is equal to first term is how much? Del phi is equal to x square plus y square into z minus here 2x square z divided by x square plus y square whole square. So into I will get plus. So in the second term, first term is 0. So we'll get minus here. Minus. In the second term, what is there? 2xyz divided by x square plus y square whole square into j plus here again you get second term got
Sir,
0. Yes. Yes, any doubt? Okay. So you'll get x square plus y square divided by x square plus y square whole square. Correct. So into k. So cancel this. Okay. So if anything get cancelled, you can cancel it. So here, except that nothing get cancelled. Now we need to find del phi value at this point 1 comma minus 1 comma 1. Okay. So this one is equal to, just substitute x equal to 1, y equal to minus 1 and z equal to 1. How much you'll get? Substitute x equal to 1, y equal to minus 1. So you'll get 1 plus minus 1 square. So 1 plus 1, 2 and z is equal to 1. So you'll get total 2 minus,
sir,
yes.
I love you, sir. Sir, you look beautiful.
Okay. So 2 minus here 2 into x square. Okay. So x square is 1 square into 1. So you'll get 2 divided by 1 square plus minus 1 square. That means 2 square. So 2 whole square into j. So I'll get this much minus 2 into 1. So 1 into minus 1 into 1. So I'll get how much total? Minus 2. Minus 2 into this. So I'll get plus 2 divided by 1 plus 1. So that means 2 square. So first term we have to write it as I here. This is I. This is j plus. So this one is 1 by. So 1 square plus minus 1 square. So I'll get 2. Okay. So let us write the overall answer for this will be how much you'll get?
One by two j plus 1 by 2k.
So this one is equal to 1 minus 1, okay. Here 1, xz, so 1 square. So I'll get 1 by 2 into j plus k. Correct. So del phi value, you got it as 1 by 2 into j plus k. So make a note of this. So implies unit vector of given vector A is nothing but it is denoted by n cap and it is defined as vector A by modulus of vector A or nothing but magnitude of vector A. So this one is equal to vector A is how much? I minus 2j plus k divided by root of 1 plus minus 2 square. So minus 2 square means 4 plus 1. So how much? I minus 2j plus k divided by root 6. 4 plus
Sir.
2, 6. So now we need to do dot product between del phi and n cap. So implies the directional derivative of a given surface phi along the given vector A is nothing but del phi dot here n cap. Okay, so n cap value is this much. Okay, del phi value is this much. So this one is equal to 1 by 2 j plus k dot here 1 by root 6 into I minus 2j plus k. So thus this one is equal to 1 by 2 root 6 you'll get into, just do the dot product. I term should be multiplied with I term, j term should be multiplied with j term and k term should be multiplied with k term. Here in the first vector I term is not there. So that means take 0. So 0 into 1 plus here 1 into minus 2. So 1 into minus 2. Next plus here 1 into 1. So how much will get total? First one 0, minus 2 plus 1. So minus 1 by 2 root 6 will get. So this one is equal to minus 1 by 2 root 6. So this much will be the slope of the that means directional derivative in a given vector. Okay, and this directional derivative will give the slope of a particular surface along with particular vector in the direction of particular vector. Okay, so I will share you one video based on the directional derivative. It will show the directional derivative concept through geometrically. Okay, after the class I will share you, just go through it. So you'll get the geometrical meaning of directional derivative. So it will give usually the slope of a particular surface at particular point. Okay. So that means this number will give only the slope of a particular point in the surface. Clear? So is there any doubt here? No?
No, sir.
We go for next problem.
Yes, sir.
Okay. So we'll try this problem, and this is the new approach of a regular problem. Okay. So let us see what are the given details here. Okay. So let us write what and all the information they have given. Okay. So given f of x comma y comma z. So that means function of several variables will give always the surface value. So this is x square, y square, z square is there. Okay. At a point at p is equal to 1 comma 1 comma minus 1. So this information related to surface. Okay. Next, given what he is asking means we need to find directional derivative in the direction of tangent to the curve. Okay, we have given three equations. So that means he is giving a position vector having x, y, z values as these three. Okay, so implies x is equal to, he has given it as e power t, y is equal to, he has given it as 1 plus 2 sine t. Next, z value has given it as t minus cos t. Okay, so let the position vector r is equal to xi plus yj plus zk. Okay, where x comma y comma z are function of t. So we are taking the position vector in terms of x, y, z, where x, y, z are the function of the parameter t. Okay, so those are the functions, the given functions. Okay, so what he has given in the direction of tangent to the curve. So how do you get a tangent? Suppose they have given the surface like this, right? The last theorem I have drawn and shown. Correct. How to draw a surface and the position vector to that surface. Suppose any shape like this you are having. Okay. Suppose at this point I am taken. Okay. At this point I am writing the position vector from origin like this. Okay. This is called the position vector r of t. Okay. If you find the derivative of this r of t, you'll get a tangent like this, right? So this is nothing but r dash. So tangent of this point at this particular point on the curve or the surface, which gives the derivative, right? So that we are going to find now. So here in the direction of tangent means you need to find position vector r and you need to find the derivative of it. Remember, derivative of it, direction of a tangent means you need to find r dash. Okay, this particular idea you should know. Okay, so implies first from r vector. So r is equal to e power t I plus 1 plus 2 sine t. So this is y value into j plus z is equal to this much. So t minus cos t j. Okay, so implies dr dash by dt. Sorry, dr by dt. I am differentiating the vector to get the tangent. R vector is equal to d by dt of e power t. So we'll get e power t I, correct. Next plus 1 plus, sorry, you won't get 1. Differentiation of this as how much?
2 cos t.
So we'll get 2 cos t j plus 1 minus
1 minus
sin t.
1 plus sin t. 1 plus sin t.
The differentiation of cos t is sin t. So I'll get 1 plus sin t j. Okay. So this is about derivative of r. Okay. Now using this r, we need to find this point. This point he has given, right? 1 comma 1 comma minus 1. So individually what I will do is, now given x is equal to e power t, according to this point, okay, what is x value?
1.
1, right? So why? Because this point is intersecting through position vector. That means this r is passing through this point. So I can substitute it. So this one is equal to 1, right? X equal to 1, where x value is e power t. Similarly, y is equal to what he has given, 1 plus sin t, sorry, 2 sin t is equal to y value, what he have given according to the point, it is 1 again.
1.
Next, z is equal to again t minus 1, sorry, t minus cos t. This value is
T is
also
equal to minus 1.
minus 1.
Minus 1.
Minus 1. Okay. And he has given the limits for t also. Okay. You need to find the t such that it should satisfy these points. Okay. Can you find such t where it should satisfy all these values? He has given the limits for t also. These are the limits. So t should lies between minus 1 and 1. Select any one number between these numbers so that
0.
you'll get, so that means if you substitute t equal to 0, what happens? E power 0. It is satisfying, right? You are getting 1. Similarly, 1 plus 2 sin 0. Sin 0 is 0. So remaining value will be 1. So
Yes.
it is satisfying this. Next, when t equal to 0, first term will be 0. Next here, cos 0 is 1.
There is
So
1.
minus 1. So when at t equal to 0, it is satisfying all these equations, right? So implies t equal to 0 satisfies above equation. Okay. Above equations. Now we can proceed. We have found the c value, sorry, t value. So implies dr by dt will be how much? Dr by dt. So just this one is equal to, substitute t equal to 0 in this equation. So e power 0 I plus 2 cos 0 j plus 1 plus sin 0. Okay. So you are finding dr by dt at t equal to 0.
Sir. In that dr by dt, you have written 1 plus sin t into j, sir. It should be 1 plus sin t into k. Here, sir.
This one, right? K. So here k. So e power 0, that is 1. So that means I plus 2j, here 1k plus k. So this is your required vector. So usually in the previous problem, he has given that vector directly. Correct. So this vector he has given directly. Correct. A vector. So now in this problem, we have found that vector. Okay. Once if you found that vector, as usual, procedure is same. So you need to find del f and using del f, we'll do the dot product between this vector. Okay, so let us find. So dr by dt you have to write here. Dr by dt at t equal to 0. Okay, now implies what is n cap for this? Dr by dt divided by
I plus 2j.
magnitude of dr by dt, right?
Yes,
So
sir.
implies n cap is equal to, here what I am doing is I plus
I
2j
plus 2j
plus k
plus k
divided by root of
divided by root
1
6.
square plus 2
6.
square plus 1. So I plus 2j plus k divided by
Divided by
4
root 6.
root 6 again. So this is the n cap value. Now we didn't find still del f value. So here only I am finding gradient of f of x comma y comma z is nothing but del f. This is nothing but df by dx I plus, sorry, dou. You have to write dou, partial differentiation, right? So dou f by dou y j plus dou f by dou z k. So implies what is del f value from this? Del f. So differentiate this equation with respect to x. Okay, so I'll get 2x y square
Y
z
square
square
z square
I
plus
plus next
2x square y
2x square y z square
y z square
j.
plus j.
Next 2x
2x
square
square y
y
square
square z
z
k.
k.
Okay. So this is the given value and we need to find this point, right? Del f at this point. Okay. So let us find it again. Del f at 1 minus 1, sorry, 1 1 minus 1. So this one is equal to, substitute it, how much you'll get? Z value is minus 1. If z square, if z value is square now, so then you'll get the first value only, all are ones. So I'll get 2i
Minus
next
plus
here
2j
plus 2j
plus
again.
2j minus 2k.
So here z value is, z power is 1. So I'll get minus 2z. Sorry, minus z. Minus zk. Okay, sorry, 1k.
Minus 2k, sir.
Minus 2k. So 2i plus 2j minus 2k. So implies directional derivative of f of x comma y comma z along, so here dr by dt, right? That means tangent. So if you are finding a derivative means that is nothing but a tangent to a curve. So here I am writing directly dr by dt is equal to del f dot dr by dt. So just find the dot product between these two. So first is do I plus 2j minus 2k dot I plus 2j plus k divided by root 6. Just multiply the numbers term-wise and tell the answer. Here 1 by root 6 into, so 2 into 1, so I'll get to 2. Next 2 into 2, I'll get 4. Minus 2 into 1, so I'll get minus 2. So plus 2 minus 2 get
4
cancelled,
by root
4
6.
by. So I'll get 4 by root 6. So that is the slope of a surface at a given point. Okay. Is any doubts here?
No, sir.
So what about remaining? Darshan?
Yes, sir.
Yes, have we got the concept?
Yes, sir.
I'll go for next problem.
Sir, that graph,
Yes. What graph? Graph you didn't understood? Hello? Graph you didn't understood? Okay, we'll go for next problem. So let us see this problem. Okay. Here they are asking find the directional derivative of the function xyz along the direction of normal to the surface, this at the point. This point they have given. So can anyone tell how to find the directional derivative for this? Is there any idea?
We have to take r vector as xy square plus yz square plus zx square is equal to 3.
R vector. R, it is not, R is a vector quantity, but this is a scalar quantity, no? Ijk is not there in this. Both are surfaces they have given, correct?
Yes, sir.
And how can you find directional derivative? So first understand the concept. Okay, here suppose again I'm drawing, particularly what I'm saying is here, directional derivative we will apply for only surface. Okay, so what is that surface means here? So I will some random surface I will draw. This surface is nothing but your xyz. So understand this, directional derivative of the function. So that means this is a function of xyz here. Okay, so that means this is your xyz. Okay. So remaining part he has given the hint for finding R vector. Okay. So this is also a surface, but here what he has given along the direction of normal to the surface. So how do you find normal to the surface? The very first problem of this chapter we have discussed how to define normal to the surface. Normal to the surface. Phi. What is the value? This is nothing but the gradient, no? Grad phi or del phi will give the normal to the surface, right? Because we have proved one theorem itself. So whenever you take a scalar function phi of x comma y comma z, then del phi will give vector normal to the surface, correct? So here grad phi will give your r vector or a vector. Okay. So let us get the clarity on given details. Let given, I am taking this xyz as some function of xyz. Phi of xyz is equal to xyz. Okay. So step 1 is we need to find the gradient for this. Okay. So implies del phi is equal to dou phi by dou x I plus dou phi by dou y j plus dou phi by dou z k. Okay. So this one is equal to, just tell me the answer. Differentiate this function with respect to x, y, z. First we'll get yz I plus zx j plus xy k. Okay, if you differentiate this function with respect to x, you'll get yz in the first term, with respect to y, xz in the second term, next with respect to z, xy in the third term. So implies del phi at this point 1 comma 1 comma 1. How much you'll get? All are ones. So I'll get I plus j plus k. So del phi or the gradient value, we got it as this much. Okay. Now given f of x comma y comma z, okay, is equal to what they have given, x y square plus y z square plus z x square minus 3. I am taking f of x comma y comma z as this much. Okay. Implies normal to the surface f of x comma y comma z. So what is the normal to the surface? This is del f. Okay. So del f I am taking it as some a vector. So now only I am denoting it as a vector, which gives the value as del phi, sorry, or del f. Okay, this gives the vector direction of the surface. Okay, where a gives the normal vector to the surface. Okay, so implies how much you'll get? Del f value you need to find. Del f is equal to dou f by dou x I plus dou f by dou y j plus dou f by dou z k. So find the derivative of this with respect to x, y, z. Now this function you have to differentiate with respect to x, y, z. So how much you'll get if you differentiate this function with respect to x, y, z?
Y square plus 2zx I
So y square plus 2zx I
plus
plus
2xy
2xy j,
plus z square
sorry, plus z
plus
square
z
is there,
square
right?
into j
Into j plus
plus 2zy
zy plus x square
plus x square
into k.
into k.
Okay. So this is about del f. Okay. Now we need to find del f at 1, 1, 1. Okay. So we'll do it. Implies del f at 1, comma 1, comma 1. Substitute x, y, z values as 1, 1, 1, 1. So how much you'll get? So here 1 plus
3i
2.
plus 3j plus 3k.
So I'll get 3i plus 3j plus 3k. Okay. So this is your A vector. Yeah. So implies you need to find n cap, right? Implies unit vector of vector A. This is equal to n cap, which is defined as A vector divided by magnitude of A vector. So implies n cap is equal to how much you'll get? 3i plus 3j plus 3k divided by root of 3 square plus 3 square plus 3 square. So this one is equal to, if you take 3 common, I plus j plus k divided by, if you take 3 square common, so I'll get root 3 you'll get. So outside 3 get cancelled, 3 root 3 you'll get here. Okay. Clear? Is it understood how you got 3 root 3? You have taken 3 square outside
Yes,
common.
sir.
So you'll get 1 plus 1 plus 1. So if you take 3 square outside, root and square get cancelled, 3 will be outside, inside 3 will be there. So n cap value is 1 by root 3 I plus j plus k. Okay. Therefore, you need to find the directional derivative. Directional derivative of phi of x comma y comma z along, here you have taken the vector as a vector, is equal to del phi dot n cap, where n cap you have defined it as a by modulus of e. Okay, so this one is equal to, just write that vector I plus j plus k dot n cap is nothing but I plus j plus k divided by root 3. So how much you'll get? 1 plus, if you multiply I quotient into I quotient, j quotient to j quotient, k quotient into k quotient. So you'll get 1 plus 1 plus
1
1
plus 1 plus 2.
root 3.
We'll get root 3 as answer.
Okay. So this one is equal to, so 3 by root 3. So this is nothing but root 3. 3 can be written as root 3 into root 3 by root 3. Root 3 get cancelled. So the directional derivative of the given surface along this direction, a vector direction, is nothing but root 3 you will get.